Hey everyone, it's Tony from Archism, and in this video we're going to be going over relative velocity and many of the concepts that kind of concern with relative velocity. That's going to be one of these. This is one of the concepts that I kind of had a hard time understanding when I was in physics. So I'm going to see if I can explain it to everyone. So the first thing that you need to understand about a frame of reference or about relative velocity is the concept of a frame of reference. So a frame of reference is an extended object whose parts are at rest relative to each other, which is from Tipler and Mosca. So what I like to think of a frame of reference as is really a person that's kind of standing still or doing a certain action. So let's say that you're sitting in a car and you look out the window. Like we most of us have sitting in cars or trains. You look out the window, you see everything going in the opposite direction of you. So you know that you're the one who's actually moving forward and the things are actually standing still. But if you didn't know that you were moving forward, you'd think that, okay, well, everything outside of me is moving backwards while I'm just standing still. Well, while someone else who was standing in a different location, say outside the window and was watching the train or car, would see, oh, well, the car is moving forward while I'm standing still. So they'd think that, okay, you are going at a certain speed or a certain velocity, while you would think, oh, they're going at a different velocity. So you guys are kind of like, okay, well, who's really right? So this is kind of what the concept of relative velocity kind of is about. The speeds of different objects depending on where you're looking at them from. So one thing that you have to remember about a reference frame is that you're assuming that the point of reference is at rest, meaning that you're measuring velocity of an object at a point in space. You're standing still, like you're not aware of your own motion. Okay, so what is the formula that we're going to be using to solve problems like this? So let's think. I thought of a little situation concerning a river. So let's say you have a river right here, and it's flowing this way. Just wherever these lines are pointing. It's flowing this way, towards the south. And then you're on a raft in this river, and you're also rowing your raft. Ooh, my drawing. You're rowing the raft towards the current of the river, or along the current. So you're trying to find out, okay, what are all the different and someone asks you a relative velocity problem. So I'm just gonna set out the variables and see how it goes. So we have three objects. So right here, let's say we have a shore and there's a person standing here. So you have the shore and you have the river, but you also have the boat. So what you would do next is you can just write the variables like this. So you have the velocity of different things. So you have let me erase that B. So you have your different velocities. So one velocity that you might see is, oh, okay, so I have the velocity of the shore relative to the boat. And then you might look again, you might see, oh, okay, I also have the velocity of the river relative to the shore. And you might look again, you might be, oh, okay, so one variable that's kind of not had to be in the front is the boat. And then you might have, okay, the boat relative to the river. So you have these three things, these three different velocities that are describing different things in this situation. So the first one, let's think about the first one, the velocity of the shore relative to the boat. So you're a person and you're on the boat and you're like, okay, I'm flowing towards the south, but I don't know that I'm flowing anywhere. I think that I'm standing still. And I see that, okay, well, the shore is kind of moving in the opposite direction that I am. So I might describe it as, okay, the shore is moving at velocity relative of the shore relative to the boat. And the velocity of the river relative to the shore. So how fast is the river going from this person's point of view? So they're looking at the river and they're like, okay, the river is going at a certain speed, and that speed is going to be this guy right here, velocity of the river relative to the shore. And the velocity of the boat relative to the river, someone's underneath you, they're looking at the boat and they're like, okay, the boat is going at a certain speed. and they're assuming that the river is standing still, but the boat is the one that's actually moving. So that's going to be that velocity. So how do these all come together in one equation? So you can think of it as, okay, the thing that's going to be going the fastest out of these three velocities is let's say the velocity of the shore relative to the boat, right? And that can be equal to, let's say they're equal to these two added up. The velocity of the river relative to the shore, and the velocity of the boat relative to the river. So if you think about it, this kind of makes sense, because the velocity of the shore relative to the boat is just going to be the negative, or the velocity of the shore relative to the boat is just going to be whatever the speed the boat is going at. So the boat is going at a speed of you rowing the boat plus the speed that the current is going, since you're rowing in the direction of the current. So that makes sense to be these two others added up. The velocity of the river relative to the shore is just going to be the current, and the velocity of the boat relative to the river is just going to be how fast you're rowing. So that's going to be kind of how fast the shore is going, which is how fast all those speeds are added up. So the thing with relative velocity problems is it's going to be different for every problem that you go into. They may give you the variables, you may have to make up your own variables, but they're very interesting problems. There's not really a one-way approach to solving them, so that's why I kind of found them difficult. So if you have any questions about relative velocity or anything that we've gone over on the channel, please send them to ArchismGroup@gmail.com. You can comment your questions also. Please like and subscribe to our video, subscribe to our channel, and as always, thanks for watching. I'll see you next time.